So, if you're listening to the recording, you are going to want a graphing calculator at some point, or I will give you the sketches, because when they configured the computers, they lost the computer or the calculator that I had on my smartboard. And hopefully they can get that back, because that was very helpful. So first thing we're going to do, very important. I used to skip over this, but then I realized how important it was, because people didn't know it as well as I thought they did. And that's domain and range is going to be the focus for today. Domain is the set of all x values that create real y values in an equation. Okay, and basically I kind of consider that a lot of times the input value, because a lot of times when you do an xy table, you choose what x to put in, it creates a y. Yes. Oh, yeah, the question here is that on your notes it says interval notation where mine says piecewise functions. That's because last year I changed it, and piecewise functions is actually going to be day 3. So that's why I changed it to interval notations on your notes. Yep. Good question. All right. And the range is then, so the domain is kind of that input you put into a function, and then the function works on it like a machine, and then it spits out some kind of y value, and that's kind of what we consider the range. It's all the y values created by what domain you just put in. Okay? So I put in the eligible, basically x values you could call it, or the domains. I put in the eligible inputs, and then it created outputs. Okay? And all those eligible outputs are called your range. Okay. Again, a lot of times we just say x and y, but it doesn't always have to be that. Questions so far? No? Sometimes writing domain and range can take a lot of time, take a lot of writing. And so then mathematicians have come up with a way that saves them time. They've come up with some symbols so that we don't have to write all of this stuff. So right now, if you see right here, this first one on the top left, interval notation, you see the blue line is pretty much covering everything, correct? So that's the set of all real numbers, right? It could be 0 or 1 or 2 or 5 or negative 17, right? It could be all of those values would work. So one way to write it is you could say from negative infinity all the way to infinity, and that looks like this, seeing I see that it's very small at the moment. You could write it that way, correct? That's a lot of writing. Or you could say all real values from negative infinity to infinity. That's even more writing, right? And so we have what's called interval notation, which is this last one here, which we're basically going to say it works from negative infinity to infinity, and we use parentheses on both sides. Because when you use a parenthesis, it means it's not included. And seeing infinity is a concept and not a number, it's kind of hard to include it. So infinity will always be with a parenthesis. Okay? And of course, I always fight with my young children's teachers on that, because they tell me it's a number, and it is not. All right. So here we see that b is included and everything less than b works. So you could do x is less than or equal to b. Or in interval notation, we know that negative infinity is over here, correct? And everything from negative infinity all the way to b works. That's why it's shaded in blue and now kind of covered in red. All right? And so we kind of go from left to right when you do this. So we'd say it works from negative infinity all the way up to whatever value that is. Maybe that's 7 right there, or maybe it's 10. Who knows, right? So we would say b, and b is included, so you put a bracket. So if the number that you have is included, you put a bracket. If it's not, you put a parenthesis. Which leads us to kind of our last option here, where it's very hard to see, but there is a hole here. I don't even know if you can see it on your notes. Can you see that there's a hole there? You might want to make it very clear that a is not included. But then everything bigger than a is included. Okay? With that in mind, we know that a is not included, and you do this from left to right when you're doing it. Okay? And for range, you do it kind of from bottom to top. All right? So negative infinity is way over here. In my depiction or interval notation, should negative infinity show up when I write it? It shouldn't, because it starts at just to the right of a is where these values actually start to work, right? So we're going to say it works from a, not including a, all the way to infinity, which is way over here. Is infinity included? No, because it's a concept, not a number. Okay? So down here, let's see if we can write these interval notations. Keep in mind where they have a and b and all this stuff will be numbers eventually, right? They're just doing it really general right now, or we are, I should say. So here's B. It is filled in. You can't tell on your notes. And everything to the left of that, because there is an arrow, is included. Again, we should start left to right. We know negative infinity is over on this side, infinity is over on that side, way over there. So now, is negative infinity part of my solution set here? Has it been shaded in? Is it part of my answers? And it is, correct? So negative infinity, with a parenthesis on it, all the way to B. Again, that could be some number, right? Who knows what it is? B and bracket. Very good, because it's included. Okay. No, here's B and C, a little bit different. B and C, because they don't go on in either direction, correct? So on letter B, both of them are open circles. Again, I know that's very difficult to see on your notes. They're both open, A and B. Who believes they know what the interval notation for this would be? Yes. Yep, A to B in parentheses. Very good. And you do have to do it in that order because we go from left to right. We do not go right to left. Okay. And this last one here, A is an open circle, B is filled in. Okay, so is it the same as the other one? Is it the same as the one we just did? No, not even close? Sure? Not close at all? All right. Oh, not close enough. That's a good answer. There you go. So what should I start with? What's the first thing I should write down? Yes? Oof. Make yours better than that. That's like a half parenthesis, half bracket. I'm not sure what that is. That's like hedging your bet there. It's one of these two. Make sure you put a good bracket in there. Now, there is a slight drawback to using interval notation, and that is sometimes it can look like an ordered pair, like in letter B. So you have to be very clear that that's what you're doing there, that you're giving an interval. Right? And the questions will actually ask you for an interval, and so that's how you're going to know. All right? They're going to say, give me the domain and range, and so it's going to be known that that is an interval. Okay? Instead of just point A, comma B. Right? Big difference. Okay? So now, that's just the notation part of it. Now we know how to write it. So, all right, why don't you take out your sheet of parent graphs that you have from the other day and try and write down the domain and range for each function. And I'll help you out by doing one of them with you here, like that one. Y equals x squared. Let's kind of do that together. So here's domain. Yeah, just write them right on your sheet. On your parent graph sheet. Yep. Domain. Now, what's domain mean again? The x values I'm allowed to put in, right? So let's just try a few x values and see what we think. Am I allowed to put 0 in for x? Yeah? Am I allowed to put 10 in for x? So sometimes it's easiest to come up with the ones you're not allowed to put in. Can you come up with an x value that I would not be allowed to put in there? Can't come up with any? So I could put in negative 1 million. Yes. Can I go beyond that in the negatives? Can I go all the way to negative infinity then and put in that value? I know it's a concept, but could we put some really large negative number in? Yeah. How about really positive? Okay. So what do you believe is domain? All possible x values that you can put in. You just told me that there's none that you can't, right? So you could say all real numbers, but I use interval notation because we want to be lazy, right? Because you could say all real numbers, right? So let's use our interval notation, though. It'll be parentheses, negative infinity to infinity. I am allowed to put in all of those values. Agreed? And again, I'm allowed to use that as an input for x right there. And then once I put it in, I'm going to square it, and a bunch of answers are going to keep flying out of there, right? Right? A lot of answers are going to come flying out of there. Are all answers going to come flying out of there? Like, for example, will the answer of 100 come over there as y at some point? That'll happen, right? And you can look at your graph. 100, let's say 100 was up here. 100 happens for there. It's there and there, right? For a y value, you see why I went up and down? Actually happens twice, okay? Are there some values that are never actually going to be an output? Are there some values that will never, ever happen? Give me one that's never going to happen. Anything less than there, any negative, right? Do you see anything in the graph down here for a y value? No. When you do range, it's kind of like domain, but domain you go left to right. In range, you want to go from the bottom to the top. You're always going from negative to positive, all right? So as I'm going from bottom to top, and as the range is concerned, you're telling me negative infinity is not a good value to try and put in. How about negative 10? Okay, so as I'm going from bottom to top, what's actually the first value I run into that actually is an output as a y value? 0, correct? It happens right here as a y value. So it actually happens, right? So 0, and what should I put? A bracket, very good. All the way. So what's some more y values that happen? Are there a lot more y values that happen then? Or are there some breaks? Or does it just keep going? All the way to infinity. Okay, so do you get the idea? Okay, I think I got another one over here. At least it looks like it. I said that we'll do this one together, and then I'll let you loose on the rest of them. Domain, again, that means which x values am I allowed to put in there? And again, sometimes it's easiest to figure out which ones am I not allowed to put in there. What do you got? What am I not allowed to put in for that x value there? There's nothing I'm not allowed to put in. So in other words, I can put in anything that's real, right? So yeah, it's the same thing. It's negative infinity all the way to infinity. I'm allowed to put them in. And as you look at x value, again, you're doing it from left to right. This will keep creeping out that way, right? And keep creeping out that way. So it's going to keep going. All right. I keep getting y values in response. How about range then? This is y values. Again, you want to do that from bottom to top. Okay. What do you believe the range is for this particular function? I've heard negative infinity to infinity from somebody. Is that correct? Yeah, because now over here, remember, the negatives didn't happen, right? Ever. They weren't going to happen. But now, look at all these down here, all those negative, again, the y values you're looking at. All those negatives happen, all these positive happen, 0 happens, so it's everything. Okay? So, why don't you take some time right now and look at the rest of your parent graphs and try and come up with domain and range. All right, for sake of time, again, if you are listening to the recording, please actually take the time to do this. Don't just fly through and just get the answers, because that's not going to help you as much. But for sake of time today, we are going to kind of move on here so that we can get through everything. So here's y equals x squared, so your y equals x to the fourth should have the exact same domain and range, right? Here's y equals x to the third, so your y equals x to the fifth. Again, the domain and range should be the same, right? But then you start running into some of the more complicated ones like these, right? And so we've got y equals the square root of x. Okay? So in looking at that, we do have some kind of domain and some kind of range. So we have to look at which x values am I allowed to actually substitute in here. All right? And your graphs can be very helpful with this, right? Or you can look at it as a function, whichever way you want to do it. So are there some I'm not allowed to put in to get a real response? Yes. Right, negatives are no good because you're going to get an imaginary response, right, from that y value. So we know negatives are no good. Okay, so if we're going from left to right, then which is the first one we bump into that we can actually put in? 0. All right. Now, does that 0 actually give me a response? Or is it just to the next of 0 that gives me the first response? 0 actually gives you a response of 0 in this case, right? So 0 is actually good. Okay, how about all the stuff to the right of it? Are those all good? Okay, do they have to necessarily give me a nice response? No, but they give me one that is real, correct? And so we would say all the way to infinity. Okay? How about range? Again, that's bottom to top. So as we do that, as we can see here, there is no negatives because that positive negative is not sitting out in front of that square root, right? Where sometimes that could be there, but that isn't, and because that's not the parent graph we're concerned with right now. And so, yeah, there are no negatives again, right? No negative responses. Does 0 actually happen as a response? You kind of told me it already does, correct? And is it the first one you run into as you go from bottom to top? So 0 to, does it go to infinity? Yep, this slowly keeps on going up. So is it going to take a while to get to 100 for a y value? Yeah, but will it get there? Yes, it will. Okay, so it does go all the way to infinity. Questions on that one? So you see how you could look at the function or look at the graph. Either way works. Okay. How about absolute value? Domain. Again, you're going from left to right. Are there x values you're not allowed to put in? Or can you put them all in? Okay, so negative infinity to infinity. How about range? no negatives, right? Because that absolute value takes care of that. And start that 0, whoops, with a bracket all the way to infinity, correct? And probably the most complicated one is this. Ooh, that's a good R. All right. Domain. So you can either look at the function or the graph. Are there x values I am not allowed to put in? There is one very particular x value I'm not allowed to put in, and that's 0. Because it's 1 divided by 0 if I try and put it in, and that is undefined in mathematics. So that is a huge problem. Is there any other value that I'm not allowed to put in for x? For example, can I put in 10 and get a response? Yep. Well, negative 100. Yep. Okay, so 0 is a problem. So you could say all reals except for 0. You could write that down. Or we could go negative infinity to 0, not included, correct? So that means take everything up to 0, right? Except 0. And then you can just put a comma and say keep going and then do 0 to infinity. Okay? How about range? Which outputs happen and which do not? Pretty much everything but 0. It's your asymptotes, right? I mean, those are your problem. So in other words, the range is the same thing, right? All right. Any questions on domain and range so far? Because if you've got these, you're doing real good. All right. So now here's where not having the graphing calculator up here could be a slight issue, but you should have one in your possession. So go ahead and turn it on, of course, your graphing calculator, and probably go to mode and make sure nothing is strange. All right. And hopefully, if you're listening to the recording, you know what strange means as far as mode is concerned. And I think I'll get the lights on for you. Yeah, you don't want it on polar. You probably want it on function. So watch out for that. So it's what, the fourth one down? See, kind of, if you have everything on the left-hand side, you're probably good. Look at these. Look at the 3 that are up on the board. Does radian degrees matter? Nope, because there's no what? No what? No what? No trigonometry, right? No sine, cosine, tangent. So it doesn't matter about degrees and radians. But make sure all your options are on the left. And then once you hit y equals, hopefully it is y equals. If you have anything in there, just go ahead and clear it out, right? And so what you're going to want to do is type in y equals is already there, right? So a big old square root, and I believe on most of yours it gives you the parenthesis, correct? All right? And then you just start typing, and we would type in 16 minus x squared, and then make sure you close off that parenthesis. Okay? Everybody find the square root button? Okay. It's above the square button. And then we probably want to go zoom standard so that we're all looking at somewhat the same thing. So you would hit your zoom button, and then standard, I think it's the 5th or 6th one down, right? Yes. I would like to say that I hope it's no surprise that it's a semicircle with radius 5, or radius 4, excuse me, but maybe it is. If we had positive and negative, we'd actually have the entire circle of radius 4, right? So I believe it should look something like that, right? Yeah, that's where you have to watch out for your calculators. That's why I love these problems. That's why they were chosen. Okay, your calculator just gets really close right here, doesn't it? And really close right there. Okay, why is that? Because the calculator only tries to find points as often as you tell it to find points. Okay, and so sometimes you have to say, all right, well, let's see if that would work. So in other words, it's trying to tell you that this x value of -4 and that x value of +4 is no good, right? Is that what your calculator is trying to tell you? So let's look at the function. Are -4 and +4 a problem with the function itself? Look back up here. Am I allowed to put 4 in there? Does it give me a response? Yes. It gives me a response of 0, right? Am I allowed to put -4 in there? Yes. What the response do I get? 0. All right. Now you notice that once you get beyond that, then it is a problem because you're taking the square root of a negative, correct? Okay. So let's try and do domain and range on this one. Yes, Crystal. All right, so domain, now that we've seen the graph, so again, sometimes you have to only take that calculator for what it can do, all right? And so here I know that I can go from where to where. What's my domain here? What are values that are actually giving me a response? What's that, not -4 or at -4? -4 doesn't work? -4 works. It gives you a response of 0. Your calculator doesn't tell you that. But again, if I put -4 in there and I square it, that's 16. 16 minus 16, 0. Square root of 0, 0. Right? So it is -4, 2, 4, both of which are included. Although your calculator does not make it look that way. Okay? Not much. Doesn't like that all much. How about the range? Like if you're going from, it doesn't have any of the negatives, right? We know that because we don't have the positive negative hanging out front there, right? It's not there. So we know we're going to take the square root of something. It's going to be just the positive version, right? So yeah. Sure. Go ahead. You want to say the answer? 0 to 4. Okay. What do you got for symbols? Both brackets. Do we have any discussion about that? 0 to 4, both brackets. So what about like beyond 4? What happened to all the infinities we were having before? They don't happen here. Yeah, it doesn't keep going. And that's also what some people think. They think, oh, it stops. Well, that must mean it just keeps going or something. Okay. So trust me, that's what some people think. Some people also think that when your calculator gives you a mistake, it's the one thing is "goto" instead of "go to." All right. Yeah. All right. How about this next one? So now you're probably on to me by now. Maybe I'm picking stuff that your graphing calculator isn't going to behave so well. And then maybe not. Who knows, right? So again, you're going to go to your y equals. You can clear out that last one that you had there and type in x. Well, how do you get to the 2/3 power? There's a couple ways you can do it. Caret button. But then if I were you, I'd be very careful and start with a parenthesis. Okay, and then type in just 2 divided by 3. Okay? And then that should give you x to the 2/3. I think if you do not put the parentheses, it does x squared over 3. All right? It's only going to do what you tell it to do. Okay? And remember, this is really saying the cube root of x squared. Right? That's really what that's saying with the fractional exponent, right? The cube root of x squared. This is kind of a fun-looking one. I believe your calculator actually does behave on this one. Okay? I believe it kind of gives you that kind of age-old seagull picture for those of us that are really bad at art. There's our birds, right? I know some of you in here are very good at art, and so this bird is very shameful to you, but this is the best I've got. All right? Domains, again, you can look at the function if you want. Okay? Now over here it was a square root, and you have problems taking some square roots, correct? Do we have problems taking any cube roots? Can we take the cube root of a negative or a positive? Yeah, we can, right? There's no problems with that. And let's face it, no matter what I put in for x, I'm going to square it first anyways. So it's going to be positive anyways. So are we really going to have any problems in what I put in here? Not really, okay? And so the domain on this one, negative infinity to infinity. I'm hoping that as you get better at this, you're going to be able to just look at the function and figure out the domain and range, okay? As you get better. How about range? Are there any y values that aren't going to come out of this? Well, let's think about what I just said. No matter what x you put in, you're going to square it, which is going to make no matter what you put in, going to make it positive. When you take the cube root of a positive, you get a positive. So every y value that comes out of here is either going to be positive or 0. Right? That's all that can come out of here. And can 0 actually come out of there? Yeah, if you put in 0. All right. And so we've got 0 to infinity. Okay. I would take a guess that this one probably misbehaves. But I look at this one a little bit differently. And if this confuses you, you can hit the delete key. All right. I look at this problem as, whoops, I did it wrong. I actually look at that as being the same thing. Do you agree if I distribute the negative, I really get the same thing I started with? Why would I write it so weird? That's a very strange way of writing that problem. Yeah, I can use the transformations now, right? Remember, this is the oddball that I told you didn't happen much, the negative on the inside. Who remembers what that does? The negative on the inside reflects it over the y-axis. And this is a square root graph that would in general look like that, correct? Okay, so let's reflect it over the y-axis, because that's what that negative would do, right? How about that negative 4 that's on the inside? Negative 4 on the inside moves it to the, not if it's on the inside, moves it to the right 4, so it moves it over here. And the 3 does what? Yeah, just kind of shoots it up quicker, right? Now, of course, would your graphing calculator be allowed to handle this one? Sure. I just wanted to show you that, you know, sometimes you can manipulate things to kind of do what you want to do. So, but I could see you making a mistake with this right here. Okay, so that's why I wanted to show you that quick. So how are we doing on domain here? And we're running out of time. That's why I'm going a little fast. I'm sorry. If you need to stop in sometime, please do so. Domain. Again, you can kind of look up here. There's only certain values I can plug in, right? Once x gets too big, what if I put x in as 10? That's a square root of a negative, right? So that's no good. So how far can I go? I can go all the way to 4 and still take the square root, right? How come no negatives cause a problem? Because it's 4 minus a negative, right? So that works okay. So your domain is negative infinity to 4, included or not? Is 4 okay? Because I can put 4 in here and get a response. How about range? Again, it's only the positive square root, right? There's no negative out there on the outside, right? So you take care of all that negative stuff before, and so, well, it's going to be a positive, so it's got to be positives, right? So everybody in agreement with that? Okay. So do you see how sometimes I look at the function, sometimes I look at the graph, especially if I don't believe the graph. Look at it and say, hey, wait a minute, it's having a problem over here in my calculator. What's going on? Okay. Any questions?